My name is Prithvisha Nath and I am the TA for this course, Engineering Mechanics. I am a PhD student in the Department of Aerospace Engineering at IIT Madras. This is week 3 for this course. So this week we will solve problems related to truss and beam. I suggest that you solve the problems along with me. So this is the first problem. Using a connection pin as reference in order to indicate the member pin force interaction on the same side of the member, principle of transmissibility is invoked if the member is under tension compression, could be either or cannot be concluded. So can you tell me which option is correct for this? So in this problem, suppose this is a member. Suppose this is a member and these are the pins, and if the member is in tension, can you tell me where the force should act on the member? So if the member is under tension, the force on the member will act like this. And similarly, the force on the pin should act here. Now, using principle of transmissibility, we can move this force along this line. Right? Is it clear? Okay. So here we have used the principle of transmissibility to indicate that the force at the pin is on the same side as the member, right? So what is asked in the question? Using a connection pin in order to indicate the member pin force interaction on the same side of the member, principle of transmissibility is invoked if the member is under tension. We can clearly see that we have used the principle of transmissibility to move that force on the same side as that of the member. So tension is the correct option. Is this like question clear to you?
Yes, ma'am.
Okay, okay. Now the second question. Which of the following members is or are in tension and the truss loaded as shown? So, as we can see, there are 11 members in the given problem. So, we are asked to find the members that are in tension. So, we can we can find out the members by looking at the joints. So, if the arrows are pointing away from the joint, we can say that the member is in tension, right? We need to see that which arrows, see the joints where the arrows are away from the joints, which suggests that the member is in tension. So here, member 1, member 2, member 9, member 7, 6, 5, 11, is there any other members which are in tension? Can you tell me? Are there any other members which are in tension? So we need to find the members which are in tension. So how can we find the members which are in tension? We just look at the joint and the arrows. So if the arrow point away from the joints, we can say that the member is under tension. So are there any other members apart from these which are under tension? Can someone tell me? And member 4 is also under tension. So members which are under one, 2, 4, 5, 7, 9 and 11. Is this clear to everyone? Here you can see that the arrows are pointing away from the joint. So I can find out the members where the joints are acting away from the joints. So is there any confusion regarding this problem?
No, ma'am.
Anyone else has any problem in understanding this problem? So I'll move on to the next problem then. A simply supported beam is loaded with a vertical concentrated load as shown. So this is a simply supported beam. A concentrated load P is acting at the midpoint, as you can see from the figure. Now by symmetry, it can be concluded that the vertical reactions at A and B are both equal to P by 2. Can someone solve this problem? You need to find out the reactions at A and B. So I will solve this problem. Now suppose this is the beam. Force P by 2 is P is acting at the midpoint, and this is A, this point is B. Now this end A is this point B is supported by a roller support. So let this be RB, the reaction force at B, and at A there is a pin joint. So, and let this be my coordinate system. Let this be RAY and RAX. This is L by 2. This is also L by 2. Now I can write this as, for Fy equals to 0, I can write it as RAY plus RB equals to P. And if we take moment about A, now if I take anti-clockwise moment to be positive, minus PL by 2 plus RB L equals to 0. So RB equals to P by 2. Similarly, if I write summation of x force in x direction equals to 0, I can see that RAX equals to 0, and from this equation RAY plus RB equals to P. these are the reaction forces at A and B. RAX is 0, RAY is P by 2, RB is P by 2. So we can see that in a symmetrical problem, the reactions at A and B both are equal, that is equal to P by 2. So it is true. Is this problem clear to all of you? Is there any doubt? So the next part of the problem, since the applied load is vertical, it can be concluded that the horizontal reaction at A is 0. So at A, initially I had considered RAX to be acting in the positive direction. Yeah, you can unmute and ask me the question. Swaroop.
Hello, ma'am. Hello? Ma'am, why there is an horizontal force in this beam, ma'am?
Sorry, can you repeat?
Why there is a horizontal force in this beam?
So this is a pin joint, right? We don't know which direction it is acting. So I'm considering x direction and y direction. It's a pin joint, right? For the roller support, we know that the force acts in the vertical direction. But since it's a pin joint, we'll arbitrarily assume one force acting in the x direction and another in y direction. Then we are finding out the forces using the equilibrium equations.
Ma'am, means in horizontal direction, this beam will move, ma'am, oscillate.
Huh?
In a horizontal direction, beam will oscillate, ma'am.
In horizontal,
Beam will move, ma'am.
no, why will it? It is fixed, right? It is supported by roller joint in one direction and fixed at A by pin joint. So since there is no force acting on the x direction, RAX should be 0. The beam will not move. It is in equilibrium, right? There is no external force acting in the x direction. You can see that by considering force, summation of force in x direction, RAX is automatically 0. That is, there is no force in the x direction.
Thank you.
Understood?
Understood, ma'am.
So the beam is in equilibrium. It will not move. So this is what the second question is about. Since the applied load is vertical, it can be concluded that the horizontal reaction A is 0. So since there is no external load in the horizontal direction, automatically RAX is 0. Right?
Yes, ma'am.
And we also found here, see, from Fx equals 0. So it's true. Is it clear to you now?
Yes, ma'am.
Okay. Are there any other doubts? Anyone?
No, ma'am.
Okay. So, the number of additional equations required to uniquely solve for the remaining unknowns. So we don't need any additional equation, right? It's already solved. We know, we have calculated all the unknowns that was required in this problem. So number of additional equation required to Now the next problem, consider a planar truss loaded as shown. So this is another truss. I suggest that you try solving the problems along with me. So can you please try solving this? So in this problem we need to find, it is said that if member DF was temporarily removed from the truss, the force in the member CE. So it is said that this member DF is temporarily removed. So in that configuration we need to find the force in member CE. So can you please try solving this problem? This is the complete problem. If member DF was temporarily removed from the truss, the force in the member CE in kilonewton is. So I'll draw the truss without the member DF. So this is E, F, there is a pin joint. So I'll assume the force is like this. And at A there is a roller support. So this is reaction at E. 25 kilonewton is acting at A and 12 kilonewton is acting at G. Now according to the problem, I have removed the member DF and I need to find the force in member C. And this distance is 1 meter. This distance is 1 meter. This distance is 1 meter. This distance is also 1 meter. Now first what I need to do is find out the unknowns that are the reaction forces. So let this be the coordinate system that I'll use. Summation of force along x direction should be 0. Now RE plus RDX plus 25 should be equal to 0. RE plus RDX equals to minus 25. Similarly, summation of force along the y direction should be 0. Fy equals to 0. Now in Fy, I can write this as Rdy, and 12 is acting along minus y direction, right? So I should put minus 12 equals to 0. So from here Rdy is 12. Up to this point, is everything clear? Is there any doubt?
No, ma'am.
Okay. Now, what I'll do, I'll take moment about the point D. And I'll assume anti-clockwise direction to be positive. So can someone tell me what are the forces that is contributing to moment about point D?
Hmm. 12 kilonewtons.
And
25.
one more is also there. Reaction at T. Reaction at T is
Yeah.
moment.
Yes,
Yeah.
ma'am. Yes, ma'am.
So R into 1 minus 12 is causing
2.
clockwise moment. So it should be minus 12 into 2, and 25 is causing again anti-clockwise moment. So 25 into 1 equals to 0.
Ma'am, 25 into 3.
25, no, 25 into
5
1.
into S1 by the soul, sir.
Yes. So RD is minus 1 kilonewton. So it is opposite to the direction that I had considered initially. That is, it is acting towards the negative x direction. Now I know RD and RDY. One more unknown is there, that is RDX. So from this first equation, this one, I can substitute the value of RD and then calculate RDX. From equation 1, so RDX minus 24 kilonewton. So the negative sign here suggests that RDX is in the opposite direction that we have considered, right? Is there any confusion regarding this point?
No, ma'am.
Initially we had considered that RDX and RE both are in positive x direction, but from our calculation it turns out to be negative, which suggests that they are in the opposite direction. So now we still need to compute the force in member CE. Now considering the point D, now I will consider the joint D. So at D, suppose this is the point D, this is FDC, I am assuming that the members are in tension, and this is FDE. So this is the problem. So I am assuming the members are in tension. I am considering this joint. So, and RDX is acting in this direction, and RDY acting in this direction. So Fx 0, I can write that FDC minus RDX 0, FDC equals to is equals to 24 kilonewton, and from Fy, summation of Fy equals to 0, I can write FDE equals to RDY, which is equals to 12 kilonewton. Is this clear?
Yes, ma'am.
Okay. Now I will consider this joint, that is the joint E. Now I'll again assume the members are in tension. So FEF, this is FED, and this is the reaction force at E, which was opposite to the assumed direction. So it is acting in the negative y direction, which is equals to 1 kilonewton. And this is the force on member CE. Now we have already calculated FE force in member DE to be 12 kilonewton. and this angle. Can someone tell me what angle will this be by looking at the truss? Can someone tell
45.
me what will this angle be?
45.
45. So FEF is equal to 1 kilonewton, and by considering forces in y direction to be 0, FCE sine 45 plus FED equals 0. FCE sine 45 minus FED. So FCE is to minus 12 divided by sine 45, which is equal to minus 16.97 kilonewton. So initially I have assumed that it is under tension, but I can see that there is a minus sign. So what I can say from this, that the member CE is under compression, right? Is it clear to everyone?
Yes, ma'am.
While solving the question, I assume that it is in tension, but from the see that there is a negative sign, which suggests that it is in compression, right?
Okay.
The member CE is in compression. Is there any question? Is there any doubt regarding this problem? So this is the problem. Is there any doubt regarding it? Can you tell? You can tell me if you have any questions.
Ma'am, why at point G you have taken summation of horizontal forces is equal to 0, and why at point E you have taken sum of vertical forces is equal to 0?
Since the truss is in equilibrium, right? At any point, the summation of horizontal force and vertical force will be 0.
Yes,
The
ma'am.
truss is in equilibrium. Is it moving? So at any, so it should be the summation of forces should be 0, right?
Yes, ma'am.
It's in equilibrium. The total force acting on it should be 0.
Okay.
We are considering equilibrium equation.
Ma'am, at every point we can take a equilibrium condition now.
Yes, sir. Every joint is in equilibrium, right? Is it moving? It's not moving, right?
No, ma'am. No.
This joint is fixed. This joint is fixed. This joint is fixed by the point D is fixed by a pin joint. E is supported by a roller joint. Roller support. The total summation of forces should be 0 for the truss to be in equilibrium.
Okay, ma'am.
Are there any other questions?
Ma'am, hello, ma'am.
Yes.
Ma'am, in roller support, why there is only horizontal force and hinge support? Why there is both, ma'am? Horizontal come vertical at support.
At roller joint, at roller support,
Why we
only a
have
horizontal,
only
only a what? Only uh,
vertical
yeah, only the
reaction?
normal component of the. I mean, uh, normal to the direction of contact. Like here,
Yes, ma'am.
in this direction, it is acting. But for pin joint, we don't know which how it will act. So we assume we basically resolve the force in two directions.
Ma'am, but in real there will be no horizontal force, ma'am, for hinge joint.
Sorry,
In reality there will be no horizontal force, ma'am, for hinge
for
joint.
which one?
Hinge joint.
No, no. That you need to find out from the equilibrium equation. There can be horizontal component as well.
Ma'am, both
See,
are, ma'am.
from RDX. See, from for this problem, the horizontal component is RDX, right? We got the value of RDX to be minus 24
Minus
kilonewton.
24.
Is it zero? No, right?
No, no.
From the equilibrium condition, you need to figure out what is the value. You just cannot assume that it will be zero directly.
Okay, okay.
So moving on. Consider the planar truss with numbers membered as shown. The total number of zero force member in the truss configuration shown is. So there are total 11 members in this truss. You need to find out the number of zero force members. Can you tell me how many zero force members are there are present in this truss? Can someone tell me how many zero force members are present in this truss? So, if you look at the members 4 and 5. Suppose this is A, B, C, D, E, F, G. Now if you look at joint A, is there any external force acting on it?
No, ma'am.
So if I resolve the forces, so at joint A, let this be FAB and FAG. So if I do Fx to be 0, it implies that the force in member AB is 0, right? Similarly, first let us consider summation of F in y direction. So suppose this is theta. So F FAG sine theta will be 0, right? From here, since theta is not 0, FAG has to be 0. Is it clear?
Yes, ma'am.
Now, if I consider Fx to be 0, the summation of forces along x direction to be 0, FAG cos theta plus FAB should be equals to 0. Now from this consideration, FAY, summation of Fy to be 0, I found out that FAG is 0. So this term is 0. So which implies that FAB is also 0. So both these members 4 and 5 are 0 force member, right? Is this everybody?
Yes, ma'am.
Now can you tell me, are there other members which are 0 force member in this truss? Just by looking at it.
At point E, ma'am.
Sorry?
Ma'am, at joint E.
Yes. Joint E. So which members? Members 1 and
Yes, ma'am.
yes. So similarly I can say that members 1 and 2 are also 0 force member. Now there are other one, I think there are more members. Can you tell me which are there? We found out these 4 members to be 0 for member, but there are others also. So can you tell me which are those? Look at joint C. So if I consider the joint C, this is CB, this is FCD, and this is FCF. So I can easily say that FCF is 0, right? Is this clear?
Yes, ma'am.
So this member 9 is also a 0 force member. Now if you look at joint G, 4 and 5 both are 0 force member. So I'll remove for calculation purpose. I will remove these two. FG, FGF, and there is an external force of 10 kilonewton. So by the above process, I can say that F summation of F along Y should be 0. Similarly, FGB should also be 0, because there is no external force to balance this force. So this has to be 0, right? FGB. Look at this joint. These two are zero force members. So I'm not considering this for the calculation purpose. Is it clear how this is becoming a zero force member? Number 11. The truss is the member is there. This member is there, but this is a zero force member, right? FGA. This member is there, but it is zero force member. Is this, or is it a zero force member? That member 11. Are there any doubts?
Excuse me, ma'am. When
Yes.
the pin joint is B,
Pin joint at
B,
B.
so that is a vertical reaction.
Yeah.
So wouldn't that affect
No,
member
at
length?
B it is a roller joint, roller support.
Yeah, roller it could have a vertical reaction, right?
Yeah.
So that wouldn't induce any force in member 11.
It will turn out to be 0 only. We
Okay.
can calculate and see, because a
Okay.
member cannot have multiple answers, right? Once
Okay.
it is a zero force member, it has to be 0, right?
Okay. Okay.
Yeah. You need to check that. We are we have calculated it from the from point G, but we can also calculate it from point G. Point.
Okay.
Yeah. So total number of zero force member. So what are the zero force member? What are the zero force members here? 4, 5, 9, 1, 2 and 11. So 1, 2, 3, 4, 5, 6. 6 members as zero force member, right? So option 6 is correct. Is this clear to everyone?
Yes, ma'am.
Yes.
Now, so which of the numbered members are zero force member? We already found that out. That is 1, 2, 4, 5, 9 and 11. Now the next part of the question, the force in member number 10. So which is so this is the member 10. We need to find out the force in this member. Now I'll consider the joint at B. Now first I need to compute the reaction forces for the truss, right? The unknown forces which acts. Now R dy plus R dy equals to 0. Look at this figure. So now similarly in x direction, R dx equals to 10, right? Is it clear from this figure? Did you understand? Is there a doubt?
Ma'am, at joint B, there is some force is there, ma'am, along BF.
Yeah, R dx is 10 kilonewton, right? From the equilibrium equation.
Not the X, ma'am. At joint B, there is one inclined force is there, no, ma'am. RDF is acting. For that, there will be one vertical force also, ma'am.
Sorry, I did not understand. Can you repeat once?
Yes, ma'am. At joint B, there is a vertical inclined force is there, no, ma'am.
No, it's a roller support, right?
Yes, ma'am. But this member is there, no, ma'am. BF is there, no.
So
It
that
will.
is internal force. You need to equate the external, external force. So what I'm doing, I'm isolating the truss. I'm removing all the. I'm drawing the. If I draw the free body diagram, so I'm drawing the free body diagram for the truss. So here if I remove the roller support, this is the free body diagram, right?
Yes,
I
ma'am.
need to remove the roller support. So this is the force. And here is a pin joint. So
RD.
so this is the free body diagram. So I am not considering the internal force. I am considering the truss as a whole to compute the reaction forces. Is it clear to you?
Yes, ma'am.
Is there any other confusion regarding this?
No, ma'am.
Okay. So this was my coordinate system. So this is how I got RDX to be 10. Now I need to calculate RBY and RDY. Now I will compute moment about point B. So if I consider anti-clockwise moment to be positive, so RDY is minus 5 kilonewton. Is this clear? Is there any confusion regarding this step?
No, ma'am.
Okay. Now I have this equation. Let this be 1. Now I know RDY, I can easily compute RBY. Now what I need to find is The force in member 10. Member 10 is this member. This is member 10. Now I'll consider this joint B. Now I have already seen that members 4, 5 and 11 are zero force member, right? So I don't need to consider them in my calculation. Though these members are present in the truss, but we don't need to consider them in calculation since it's zero, right? So this is just the reaction force, which is equal to RBY. This is joint B. Now if I consider f summation of f along y direction to be 0, RBY, can you tell me which angle, what angle should it be by looking at this figure? This angle?
45, ma'am.
Yeah. RBY plus FBF sine 45 equals to 0. FBF sine 45 equals to minus RBY. So FBF, RBY is how much? 5 kilonewton, right? So minus 5 by sine 45. So this is equal to minus 7.07 kilonewton. Is this step clear? How I am getting this?
Yes, ma'am.
Are there any doubts regarding this? So FBF is force in member 10. I have considered this joint and computed the force. Are there any confusion regarding this thing?
No, ma'am.
Anyone else has any? So next part of the question. The ratio of the force in member number 6 to that in member number 7. So we need to find out the ratio in member number 6 to that in member number 7. That is these two members. Now, joint B itself, we can compute the force in member 6, right? So this is my joint B. So from here only I can find the force in this member, right? Member 6. Just by considering the force along x direction. So summation summation fx equals 0. FBC plus FBF cos 45 is 0. So FB is minus of FBF cos 45. This is for member number 6, right? And member number 7 is what? And considering joint C. So this is F Now we have already seen that this member is a zero force member initially, right? We have already found that out that member 9 is a zero force member, right?
Yes, ma'am.
Member 9 is a zero force member, so FBC equals to FCD. FCB equals to FCD. Now this member is member number 6 and this is member number 7. So we can see that equal and opposite forces are acting on both these members. So the ratio is 1. Is it clear?
Yes, ma'am.
Others, do anyone else has any doubt?
Ma'am, I had a doubt
Yes.
about the member 6 and 7.
Yes.
We have found the ratio to be 1.
Yes.
Now, just the nature, whether it is tension or compression, we just had to discuss that. As per this, member 6 is in tension, correct?
Uh,
looking at this diagram.
Yeah, we need to find the. Yeah, so wait.
Because these are the reactions at the pin. So what X on the member is equal and opposite.
Can you repeat the question once?
That this member 6 and member 7.
Yes.
I was just wondering what would be like. I think one member would be in tension and the other one would be in compression, right?
One member in tension. 1 minute. One minute. R6 is in tension. R10 is in compression. R6 is in tension. R6 is in tension. R6 is in tension. And I'm assuming, I don't know FCD, right? That is in, for member 7, I don't know.
Okay.
R6 is in tension. You can see this, like FBF is in minus. So this is FBF. This member is in, actually is in compression because I got in negative, right?
Yes.
So this is actually, this should be in reverse direction. Understood?
Yes.
This member is actually is in compression. So ultimately member 6 is in tension.
Okay.
Is there any confusion regarding this?
No.
So if I write like this, this is actually like this. Did you understand?
Yes, ma'am.
Okay. So accordingly, this sign will be minus if I consider this right image, right figure.
Yes.
So this is the explanation. So the ratio is coming out to be 1. Is there any doubt regarding this? No doubt, right?
No, ma'am.
Okay. So the next problem. A truss is arranged such that each of the smaller triangles is equilateral. All dimensions shown are in millimeters. What is the magnitude of net reaction force in kilonewton at joint A? So can you try this problem? The same process you have to follow. Draw the free body diagram and then find out the reaction forces. So at point there is a point A, there is a pin joint, and at point B there is a roller support. So can you just find out the reaction forces? This is just the same process you need to follow as the earlier problems. I'll suggest that everyone should try this problem. Now, did anyone try this? Could you find out the reaction at A?
Yes, ma'am. I got the reactions.
Sorry?
I got the reactions at RB and RBY. I got an RAY.
RAY. So, what did you get? RB?
RB is 40 kilonewton.
Yes, 40, and RAY?
10 kilonewton.
Yes.
And RAX is 0.
Yeah. Yeah, that's correct. So, I'll solve this question. RAY is in the opposite direction, that in opposite.
Yes.
Yeah.
To that which they were doing.
Yeah. So I'll solve this question. RAY plus RB is 30 kilonewton. Now I will compute moment about the point A. So RB into 3000 minus of 20. So what is the distance that we should consider for this force at 20? So I need this total distance. This total distance, right? We know that this is 1500. And can someone tell me what should be this angle?
Degree.
30 degree, yes. So this should be 1500 sine 30, right? So the total distance is 3000 plus 1500 sine 30 degree. And for this, similarly for this 10 kilonewton force, I can compute this total distance minus 10 into 3000. 3000 is for this distance. From this point to this point, this is 3000, and I need this much distance. So it is 3000 sine 30 degree. Is it clear to everyone? These are equilateral triangles, so this angle is 60. So this angle has to be 30, right? So 3000 plus 3000 sine 30 degree equals 0. So So RB finally comes out to be 40 kilonewton. Is there any doubt regarding this? Up till here, is there any doubt?
No, ma'am.
Okay. Now, from this equation, I will substitute the value for RB, that is 40. So RAY equals to minus 10 kilonewton. We are asked to find out the magnitude, so it is simply 10 kilonewton. Now the next part of the question, what is the magnitude of net reaction force in kilonewton at point B? We already found out that is 40 kilonewton. It is 40 kilonewton. Now the next part. Without calculating reaction, the force in member DG can be calculated using a single cut section and one equilibrium equation. Can we compute the force in member DG using a single cut section and one equilibrium equation? DG is this member. Can you tell me if I make one cut, if I cut a single section, can I find out this force at DG? I need to find out this force using only one equilibrium equation and one cut. Can you tell me how can I find out this? So if I make a cut here, how should I make a cut? Can you tell me? Can anyone tell me? Okay, then first we'll find out the force in member EH. Can you tell me how to find force in member EH? This member. If I make a cut here, can I find out the force in member EF? First we'll find out the force in member EF. Then we'll go back to this question EH. Can I find out force in member EF? If I make a cut here. So what will the truss look like? First we'll find out the force in member EF, then we'll go back to EH. So this is point I, this is H, this is E, this is F, not E. So, and here is another member. So F, FE, F, HG, F, HG. Is this clear? How I am getting this? I am considering the section at right of this cut. So I am left with these members. Is it clear?
Yes, ma'am, but you are assuming all are tensile, ma'am.
All are?
Tensile forces acting.
What?
All are tensile forces are acting, ma'am, at that point.
I am making a cut in this section and I am just separating them.
Okay, ma'am, but all are acting outward toward the point, ma'am.
So I am assuming that.
Okay,
I will get out, I'll get the final answer by solving, right?
Okay.
So these are the members. So this distance is 1500. This is 60 degree. Now I'll consider moment about H. So anti-clockwise is assumed to be positive. So minus 10 into 1500 minus 20 . So what is this distance that we should consider?
Okay. 1500 cos 60.
Yes. Minus FE 1500 sine 60, right?
Yes, ma'am.
Is it clear?
Yes, ma'am.
Yeah. So I'll get FFE from this thing, FEF. So equals to minus 10 minus 60 minus 24.09. Is there a doubt in this? I found out FFE from this force I found out, right?
Yes, ma'am.
Now I'm going to find out force in member F in member EH. This force and this force has to be found out. Okay. No. So I'll first calculate force in member GH. That is this member. I'll first find out the force in member GH. Now I will consider the other half of the truss to compute this force. So now I'll consider the rest half, not this half, the left portion of the truss. The left portion of the truss will consider for calculating force in member GH. Okay. So here there were reaction forces, right, of 10 kilonewton. This is A, B. Here it was 40 kilonewton. This is D, E, C. This was point G, F, G, H. We have seen that the force in member EF is acting in the opposite direction. So we'll make the direction reverse, FEF, and here was another member, that is member EH. FEH. So FGH minus FE plus this angle is 60, right? So FEH cos 60 equals to 0. Similarly, considering in the y direction, FEH sin 60 plus 40 minus 10 equals 0. FEH sin 60 equals to minus 30. FEH minus 30 by sin 60, which is equal to minus 34 by 64 kilonewton. Now I got force in member EH. So this was one of the question here. So FEH equals to minus 34.64 kilonewton. Right? Is this clear?
Yes, ma'am.
Is there any
Ma'am, in horizontal direction, there is a reaction force at A, is there no, ma'am? Next direction.
which one?
At the joint A, there is reaction force in X direction.
We already calculated that, right?
We have calculated in Y direction.
RAX has to be 0, right? If I consider class as a whole, RAX is 0, right?
Yes, ma'am.
If I consider X to be 0. So is there any external force which is acting on the truss in the X direction? On the truss, see the figure. Is there any external force which is acting in the X direction?
No, ma'am.
So RAX has to be 0, right?
Okay, ma'am.
Is that clear?
Yes, ma'am, clear.
Ah. So from this, so only RAY is there. So is there any doubt in this steps? Are there any doubts? You can tell me if you have questions. Is there any?
No, ma'am.
Okay. So next, finally, we need to find out the force in member GH. We already found out these two, right? These two we have found out, right? Now the remaining forces, the force in member GH. Now we know force in member EH. Now we'll just substitute. Fg minus Fe plus Feh cos 60 is 0. Now Fgh equals to Ffe plus Feh cos 60. This is coming from this equation, okay? Summation of fx equals to 0.
Yes, ma'am.
So Fgh equals to, what was it?
Minus 23.04.
09. 23.09. Here I won't write the minus because I have already reversed the sign. See,
Yes, ma'am.
I have already reversed the direction. Here when I was assuming it was in tension, right?
Yes, ma'am.
For the other half of the truss, I was assuming that the member was in tension and then it came in minus, right?
Yes, ma'am.
So I automatically reversed the direction when I was calculating for the other half of the truss. Now see, I have reversed the arrow, so it implies that this member is in compression. So I'm not putting the negative sign again. I've already considered it while writing the equation, equilibrium equation. See, FGH minus FFE. Did you understand this? When I was calculating the force FFE from this portion of the truss, see, I've assumed it to be under tension.
Tension.
It is away from the joint, right?
Yes, ma'am.
Is it clear?
Clear, ma'am.
But I got it to be negative. So this suggests it is in compression, right?
Yes, ma'am.
So when I am calculating for the rest half of the truss, I am already reversing the arrow since it is in compression. And then I am writing the equilibrium equation. So I am taking into account this minus sign. Understood?
Understood.
So FFE 3.09 plus FEH, that is wait, FEH, what did I get? FEH as FEH is minus, this becomes this should be minus. So FEH is minus of 34, so this is plus 34.64, which is equal to T cos 60 into cos 60. So this is 0.41 kilometer. Did you understand?
Yes, ma'am.
Okay. So the force in member GH is 40.4. Can anyone tell me this question? The force in member DG. How should I make the cut so that I can calculate? using just see if I like this. How should I cut it?
Ma'am, can we just cut a corner at point G, like where three members get cut, EG, EG and EH?
Like this?
Yeah.
But they have asked without calculating the reaction force. And only one condition you should use. See in this question, without calculating reaction, the force in member DG can be calculated using a single cut section and one equilibrium equation. You just have one equation.
So it should include the 10 kilonewton and 20 kilonewton forces.
Yeah, so how should I make the cut? Can you tell me?
Just be a horizontal line cutting DG.
Like this?
Yeah. I think too many unknowns.
Yeah. This thing you people try, okay? Just try doing this. So are there any other doubts in these problems?
Ma'am, the notations that you use, like you
Which one?
asked, the notations, like we
Yes.
found GH, right? Force in member GH,
Yeah.
the calculation. Can you please show the cut section, ma'am?
Yeah. Which one?
GH, FGH, the last one. Yeah, the forces in the two joint G, the sketch.
Yeah.
Yeah, this one. So, is there a way of denoting for the notation of the forces? It be like GH, the first letter should be the pin joint we are considering, or it can be FHG also is fine.
Uh, you can just watch the lectures, the convention which professor
Okay,
followed.
okay, okay.
Okay. Are there any?
No, ma'am.
No, ma'am.
Okay. So we'll stop here then if there are no doubts.